Everyone, welcome back to my channel. So this is another video where I have brought a very important video, which is a very important topic for every electrical and electronics engineer. So this is a very important topic for whoever is in a circuit branches such as electronics and electrical. So let me tell which is that topic. Very important topic. There is nothing which can never use this in electrical and electronic streams. So that is what you might guess it now. So that is Ohm's law. Okay, this is the Ohm's law. Why I have brought this video? Many have understood this Ohm's law as nothing but V equal to I into R. So this is the Ohm's law according to everyone. So I'm going to tell what is the real meaning of Ohm's law and how it is used. So first we will go with the statement of Ohm's law. So what does the Ohm's law says? For the conductor means nothing but we can take an wire, resistor or anything. I am taking an wire. So this is a wire. So the current flowing in this wire, whatever the current is flowing in this wire, is directly proportional to the voltage applied across it. Whatever the voltage is applied across this, it is directly proportional. Means what? I is directly proportional to V. Actually it is not V, it is a potential difference. Means if we consider this as a one node and this as a one more node, so it is going to be V1 minus V2. So this is the actual meaning of Ohm's law. What it is? The current flowing through the conductor is directly proportional to the voltage applied across it. What does it mean by across it? Means this side and this side. This is the meaning of across it. So we will write it as this way. And for further simplification, what they have made, they have took this V1 minus V2, we will take it as a voltage difference. Means we will take it as a delta V and we will put it as a directly proportional to I. Then to remove this proportionality, they have put one constant, that is R. So this is what the Ohm's law everybody remember, and it is to be. There is nothing wrong in that because it's a very easy to remember this thing. And there are many other things which I have to clarify today. These are not mainly related with the Ohm's law. Ohm's law is mainly nothing but this much. This is the Ohm's law actually. But the things which I have to clarify is that I will take one circuit, simple circuit. That is, I will take this. And here R is nothing but a resistance. I have already made a video on the resistance, that is parallel and series connection. In that I have already told what is resistance, and there are combinations of resistance. I have told it everything about that. But also I will tell in this video what is the resistance. Resistance is nothing but it is something which opposes the flow of current. Actually it is not opposing the flow of current. It is opposing the flow of electrons, due to which the opposition of current happens. So that is what I am going to tell here. See, if I give a battery here and this is a resistor R and this you take as a V. Okay. Now if you see, this is a positive side, the current will go in this direction. One important thing everyone forgets is the thing about electrons. See, electrons, there must be electrons in this all materials, whatever you are using, the resistor, wire and everything. So if here we have applied something with a positive polarity and negative polarity, then electrons which are negative polarity, they will attract to a positive polarity thing. Doesn't mean that the direction of electron is in this direction. And what is the current? Current is nothing but which is generated due to the motion of electrons. So that's what the current is. and current direction is going to be the opposite of electrons. This is what very important thing to be remembered corely. Everyone forget about this. And next thing, what is the resistance? Which opposes the flow of electrons. That is the resistance. And when does it happens? See, by using the Ohm's law equation we can tell it. See, as the voltage increases, what does increases? Current increases. Resistance is a constant, it doesn't increases or decreases, but while calculating for some circuits it is not used as a constant because we are calculating the resistance itself there. There are also some situations I will tell you. See, V is directly proportional to I. As voltage increases, this current increases. Why? Because as voltage difference between this resistance increases, whatever might be the resistance value, it will break through the resistance and electrons start attracting to this battery polarity. That's the meaning. If voltage is decreasing, electrons will not able to break that whatever it is resisting, this resistance, and current will be decreased due to that. So it is clear that if voltage is less, current is going to be less. Why? Because it means that it is not able to break through the resistance. That's what the meaning is. So, and there are many things I want to tell. That is, if you see, we'll take one small example. So, and there is no such laws which don't use the Ohm's law. There is no such law, because if you see some laws such as Kirchhoff's voltage law, Kirchhoff's current law, they all use this Ohm's law. Without Ohm's law, these laws are not able to derived. Okay. So here the main thing is understanding of the resistance use, and understanding of the battery, and understanding of the current. And one thing which is always the same, that is current direction is from higher polarity, lower polarity, means high voltage to low voltage. Okay, that's it for today, and this simplification I will show in the next video with the help of the software known as Proteus, or else I will think about it, and I will do some videos more on the Ohm's law for understanding the better. That must be in such a way that you may never forget the Ohm's law. Actually, the Ohm's law is never forgotten by anybody because it's very simple. V equal to I into R in the mathematical way. But in a practical way, you see there are many applications of Ohm's law that we don't use. See, mainly Ohm's law can be used whenever, see, there is no such thing that if you put the voltage to something you will get a current. See, sometimes you need a current of 1 ampere. How will you achieve that? You will achieve that means I am going to tell you some example of my own thing. See, I have made some circuit here for step down. Step down is done by what? Transformer. Then I have used the bridge rectifier to make it to DC. This is bridge rectifier. Then I got DC here. Then I used some regulator for the purpose of voltage. Then one small thing, that is I want to charge a lithium ion battery. The battery is present here. Now to charge this lithium ion battery we need a minimum of 1 ampere, and from the regulator, if you think you are charging a one single battery, if you think lithium ion battery is going to be 4.2 volt. Okay, and in the minimal way it will means when it is in a zero condition it will be having a 3 volt, and at the regulator place I am going to have the value of 4.2 volt that is required to charge this battery. Now I required a 1 ampere current. How will I bring that current? Nothing you will do, you will apply the Ohm's law, that is to calculate the resistance value. I told you it will be constant, but it is mainly used to calculate that value, constant value, we will use the voltage and current. See, I'm having the already a voltage difference, that is 4.2 minus 3. So to calculate R, what I'm going to do this equation in the shifting way. R equal to what? It will be V by I. So what is the V? It's a voltage difference. So it is going to be 4.2 minus 3. So 4.2 minus 3 is going to be what? It is going to be 1.2. What is 1.2 divided by 1? I want a current of 1 ampere. I already chose it. I am having the voltage, I am having the current. I am going to do 1 ampere. So what is the 1.2 divided by 1? It is going to be 1.2 ohms. So this is the value I have to use in between this battery and regulator. I don't know this circuit is going to work or no. I am giving a small example. Why the hell the Ohm's law is derived and where it is used. It is used in a very big things also. There is nothing which, it is not a small thing, that is V equal to I into R. You tell it as a very small thing, but it's a very important thing. It is used in the many things, anywhere, wherever it is required to calculate the resistance value for particular voltage and required current. Okay, that's it for today. Thank you.